Welcome, Junior Takis. My name is Mrs. Ramlal. This video is on the section Animal Tissues. And in this video, we will be looking at the question 1 of the exam questions. Now, before we actually do the exam questions, make sure you watch my theory videos, make sure you print my worksheet, and have the memo with you at hand. Right, let's get down to question 1. Now, if you look at question 1 is based on the 3 graphs below. Now, let's read the introduction. The graph below shows the amount of hemoglobin and number of red blood cells at different altitudes for members of a Himalayan climbing expedition team. Right. So in the one graph you have, the first graph you have the grams of hemoglobin in 100 centimeters cubed of blood over certain expedition days. Then you have the altitude of the expedition, members in meters over the expedition days, over which you can see is 100 days. And in the third graph, you have the number of red blood cells in 1 millimeters cubed of blood over the 100 days. Now, so we can see now from this graph that hemoglobin and red blood cells obviously have an effect at in these members at different altitudes. Now, this is a very nice question. I've chosen this question so that you can, it's a very nice application question where you link altitude, hemoglobin, and red blood cells. Right, so let's get down to the question. 1.1, in what unit was the amount of hemoglobin in the blood measured? Well, so what you have to do now is look and see. We look at amount of hemoglobin, so this is the graph we're supposed to be looking at. So they want to know the unit in which the amount of hemoglobin was measured, of blood was measured. So here you can see it says grams of hemoglobin in 100 centimeters cubed of blood. So you can see that this unit is grams per centimeters cubed of blood, right? So if we go, I've attached the memo to make it easier for you to see what we're looking for. So grams per 100 centimeters cubed of blood, right? That was easy to get, right? Right, let's go back to 1.2. Now, 1.2, how much hemoglobin was present in the blood of the team members at the beginning of the expedition? So, how much of hemoglobin? So, there's your beginning of your expedition. How much of hemoglobin present at the beginning? So, what will we do? We have to now take this reading here. And it looks, the line looks between 14 and 15. So that will be 14,5. But again, don't forget, it's 1 mark, but we must have the unit, grams per 100 centimeters cubed of blood. Okay. So that was also an easy one. Let's get to the memo and see, yes, that's what we wanted. Here, the memo didn't give you marks awarded for units because you already got it here in your first question. You don't get marks twice for one answer, the same answer. Right. Okay, so that was not too bad. The graph seems easy. The work seems easy. Let's look at 1.3. How many red blood cells were present in 1 millimeters cubed of blood 38 days after the beginning of the expedition? So we're looking now red blood cells. That means we have to look at this graph here. How much red blood cells? 38 days. So what I have to do here now, I have to look for 38 days. And it looks like it's going to give me very close to about 6 million red blood cells per millimeters cubed of blood. So again, you can see, so let's go to the memo. So 6 million. Now, you can see that the first 3 questions are very, very easy. It's just reading off a graph. But it's very easy for you to get confused in these types of graphs. So make sure when you're reading, you concentrate, you look at the right graph. Right, now 1.4. What is the maximum amount of hemoglobin present in the blood during the expedition? Maximum amount of hemoglobin. So let's go back to our graph. Maximum amount of hemoglobin. So let's go. Maximum amount of hemoglobin will be what? 20 grams, because that's the maximum amount of hemoglobin. So 20 grams per 100 centimeters cubed of blood. So there we go. We can see that there. Don't just give the unit, the answer, 20 grams. Give the unit as well. Whether you'll be awarded marks or not, do the right thing. Always have an answer and a unit. Right, let's look at 1.5. How many days did the team spend above 4.5, how many days did the team spend above 4,500 meters? So we can see now we have to look at altitude. Now, altitude above 4,000. So that's what we have to do. And we have to take our, and that's how you will find your answer. And it should be something like 60 days. But let's go back and see if we get that for ourselves. 90 minus 60, yes. So yeah, that is 90. This will be 30. So yes, 60 days. Right. Now, 1.6. As the climbers spend more time at higher altitudes, what happens to the numbers of red blood cells? Now, it's only 1 mark. They don't want an explanation. So this is a very nice question in grade 10. You learned this in environmental studies with altitude, and you learned it with the red blood cells. Or if you did not learn it with the red blood cells, this is how your application question will be asked. Now, we know at higher altitudes, the air is thinner. What does it actually mean? It means that there's less oxygen. And if there's less oxygen, to compensate for that, your body will produce more red blood cells. So what will happen to the number of red blood cells? It will increase. If there is more red blood cells, what will happen to the amount of hemoglobin in the blood? Yes, the amount of hemoglobin will also increase to carry more oxygen to all the cells. So let's go and see our memo. Yes, just increase. That's it. Simple. Please, for 1 mark, don't give a whole explanation. There's 1.7. Explain your answer in 1.6a. So A, they want to know why the number of red blood cells are increased. And I just explained it to you. So let's go. The air is thinner. That means there's less oxygen. And to compensate for that, more red blood cells will be produced. And if there's more red blood cells, obviously in turn, that will increase the amount of oxygen. Okay. Thank you for joining me and watching this video on the exam question 1 on animal tissues. Join me and watch all my other videos as well.